Welcome back to 3 Inquisitive Kids. Continuing our unit on geometry, we're going to be now looking at circles. Rectangle ABCD is inscribed in a semicircle with diameter FE, as shown in the figure. Let DA equal 16, and let both FD and AE equal 9. What is the area of ABCD? Pause the video to see if you can find this on your own. As you can see, we have the shaded region ABCD in here. And to the naked eye, it might sort of seem like a square, but remember, in math competitions, that's never the way. Don't just assume something without proof because it looks like it. One trick when it comes to solving geometry problems that contain circles is that whenever you have a circle, always pay attention to the radius. Why? Because the radius is a special parameter of a circle that is consistent all throughout. In a circle, the radius always stays the same. Now, going back to the problem, we're trying to find the area of ABCD. ABCD is a rectangle, and the formula of a rectangle is area is equal to base times height. We already have its base, which is 16, so we're going to try to find either CD or BA. So let's call BA x and CD x. What is x? Because once we know x, we can find the area. Now let's think for a moment. What are we given here about the circle itself? Well, we really don't know the radius yet, but we do know its diameter. Because this is a semicircle, it means that this entire length here is its diameter. So we can add together, so the diameter here is 9 times 2 plus 16, giving us 34. So we know that the diameter is 34, and the radius would be 17. Now, where do we use and apply what we know here? The next thing we do is use the Pythagorean theorem to connect the midpoint of the semicircle and connect this with C and B. So now we have created two identical right triangles. We know that each of the bases of these two right triangles is 8 because that's 16 and a half. And we know that these are both the radiuses of the circle. These are all the radiuses, which is because the radius never changes throughout a circle. So because we know that this portion is 17, we know that the length of C, let's call this G, we know that CG is 17 and BG is 17 as well. Now we can use the Pythagorean theorem to find out x. We know that x squared plus 8 squared is equal to 17 squared. X squared is then equal to 89 minus 64, which is 225. Therefore, x is equal to 15. And now that we know x is equal to 15, we already know the base and the height of the rectangle. Now we can multiply. 15 times 16 is equal to 240. So the final answer of this problem is 240. Now there we have it. We know the answer to our first problem on circles. Remember, once we found out the radius and all of the parameters of the circle, we were able to solve the problem pretty quickly. Again, thank you so much for watching 3 Inquisitive Kids, and we'll see you next time.